Hi all. So in this video we are going to discuss about image classification and deep learning. So we're going to do image classification with convolution neural networks and WAN-DB and TensorBoard in TensorFlow. So first we have to install the essential libraries and then weights and biases for experiment tracking and TensorBoard for visualization. These tools help us to monitor performance really well. And after importing the required libraries like NumPy Pandas and Seaborn for plotting and Scikit-learn for evaluation and TensorFlow for deep learning model, we can proceed with the next steps. So basically we initialize weights and biases with our training configuration, therefore the number of epochs, batch size, optimizer and loss function. Then we set up TensorBoard to log training data locally. So we are using the CFAR 10 dataset, which contains approximately 60,000 columns and 32 cross 32 color image across 10 classes like airplane, cat, truck, and so on. We normalize the pixel values to range from 0 to 1. So here's our convolution neural network. We use two blocks of conv 2D to batch norm and then to max mulling and finally dropout. Then we flatten the output and use dense layers to classify into 10 categories using softmax. So now we train the model. So thanks to WAN-DB and TensorBoard, we can track accuracy, loss, and more in real time. So then we visualize how the model performance improved over each epoch, both in training and validation, accuracy, and loss. This helps identify overfitting or underfitting. So, using Keras plot model, we generate a clear diagram of our CNN architecture, which is perfect for documentation and explanation. So, after that, we're going to evaluate on our test set. So, once training is complete, we evaluate the model on the unseen data to measure its generalization. Our accuracy here is about around 76%, pretty solid for considering we have used only simple CNN. And coming to the classification report, this detailed report shows metrics for each class, therefore precision, recall, and F1 scores, which are great for analyzing which classes the model struggles with. And basically, this confusion matrix helps us to see the truest predicted labels in a visual format. We can quickly spot which classes are getting mixed up. Therefore, the highlighted one row or column where confusion is high, example like cat versus dog. So this the tensor dashboard, and to wrap up, we have just built and trained a CNN on CIFAR 10 dataset and tracked everything with WAN-DB and TensorBoard and perform a detailed evaluation. Thank you.